Excited to talk about settings in the DJI Pilot app with the Mavic 2 Enterprise series today. And before we jump in, obviously we are using the Mavic 2 Enterprise series as the example here, but pretty much all the settings we cover are going to be applicable to other drones. Starting off here with the Mavic 2 Enterprise, as when you get into a more complex system, such as the Matrice series, these previous settings are going to be built upon when moving forward. So it's key to understand these first, even though it's with the Mavic 2 Enterprise series, and then learn additional features on top, or just learn the settings that you're working with the Mavic 2 Enterprise series. And when we bring up a lot of these settings, we're going to go ahead and understand kind of a little more in depth about what the settings mean for our actual operations. So without further ado, we went over the main menu before, but now we're into the point where we can go ahead and select manual flight to enter camera view. Again, this is the Android application here. iOS, you'd only have this option. The right side is mission flight, which we'll talk about later on, but that is for automating flight. But in manual flight, the first thing that's going to pop up is a checklist, which includes key items you're going to need before takeoff. We're actually going to circle back to this at the end because a lot of these items we're going to go into more depth, and they're also a part of the more in-depth menu that's in the app. But just to be aware, this is what pops up when you first open the app. You can hit the X in the top right just to exit it once you've gone through these. But for this example, we're just exiting out because we want to go into the detailed settings. And then this is the main screen here. After exiting the checklist, you're going to see that camera feed. And before we kind of cover these in-flight items, the fun of taking off, we're going to go ahead and cover all these detailed settings today. So that's just the three dots in the top right. And then you can see here, we have a second sub-menu. So all of these items will be different sub-menus that are part of the detailed settings. So first one here being flight controller settings. And the first concept we need to cover is the home point. So first of all, just kind of going over the concept of a home point. Our drone and mobile device both have GPS, which results in a GPS location. Just like if you're in your car driving somewhere using a map software, the phone also knows where your car's at to provide directions. So when our drone connects to GPS after being turned on, it's going to set its location as the home point, and it will also reset that home point when you initiate a takeoff. So if I turn the drone on and it's kind of by me, connects to GPS, going to get a home point. If I go put it down at a takeoff location, spin out the props, it's going to set another home point location, and you'll hear the application home point set. Probably heard that so many times, I can't even remember the exact wording, but you get the idea. But this home point is important because if during flight there's a disconnection between the drone and the remote controller, we want the drone to go home back to this home point and land. And this was really a great safety feature for all UAS because it adds a layer of protection there where if the drone disconnects from the RC, as long as it's still connected to GPS, it's going to be able to come back and land in that location. And it's surprisingly good how good this feature is. Some of you might have experienced it before. But there are some situations where that home point, we might want to change that during flight. So as I talked about, whenever you take off the drone from a location, it's going to set that new location as a home point. There are specific situations, for example, public safety. They may fly to a hazmat scene, land the drone, and they're getting some readings with some tools that are attached to the drone, and that home point is then set where the drone landed downrange from them, where they want the home point to be right next to them. Or in this case, the option would be for them to set the home point to the location of the remote controller. You could also use the drone's GPS location to set a home point as well as an option. But just important to know, maybe your takeoff spot has been compromised during takeoff as well. So these are probably rarely used, but when they are used, very important features. So home point settings defaults to our drone's takeoff point, but we can set that home point to the location of the drone or the location of the RC. Next up, looking at enabling multiple flight modes. So enabling flight modes, just for your reference, allows you to enable flight modes outside of P mode, or what we call positioning mode. So there's a description there in the app, but just to go a little more in depth here, or more layman's terms perhaps, positioning mode, as I said, is the default, and that's going to be what most pilots are using the majority of the time. You're able to use all your intelligent features, the obstacle avoidance is enabled. You can disable it, which we'll talk about later, but you have the obstacle avoidance ability. Sport mode increases your max flight speed, but obstacle avoidance is disabled. So potentially could use this on a windy day, aircraft struggling to get back to land. Maybe the wind's really picked up during your flight or something, or you really need to get the drone from point A to B as fast as possible. Tripod significantly decreases the max flight speed, so kind of the opposite of sport mode. So it's good for making small movements. You want to use this when maybe in an inspection scenario, or if you're just trying to move the aircraft a very small amount of space, for lack of a better term. And finally, ATTI mode here, or attitude mode. The drone's going to maintain its altitude, but not the positioning on its own because the GPS is turned off. So it's going to go ahead and pretty much drift in the wind. This can be useful for cinematography because the drone's not going to come to an abrupt halt when you take your fingers off the sticks. It's also good to use ATTI mode for practice because we can't depend on always having GPS. Ideally, most of the time we will, but you need to be prepared in case you're not getting a GPS signal or you lose GPS signal and you manually need to land the aircraft in ATTI mode. So a good mode to practice in as well. Here's a quick example of ATTI mode. It's actually with Matrice 300, it's just the video I had handy, but you can see switch to ATTI mode and the drone slowly starts to drift to the left. You can see the wind's coming from the right side of the drone, pushing it to the left, and you can see when positioning mode is switched back on, the aircraft abruptly stops and starts using that GPS positioning to stay in one spot. So that's kind of the different flight modes. Here in the Pilot app, you can enable sport positioning or tripod, and that's the actual switch on the remote controller that you can see right there under flight mode, or you can change it to be sport positioning and ATTI. So as long as you have this enable multiple flight modes on, you can go ahead and use that switch to go between the three. Moving down here, we just talked about the idea of a home point, but now we're getting into how the drone returns home. So just looking at that graphic here, you can see the drone's going to go up, over, and down. Maximum altitude is the maximum altitude of your drone during your flights that day. And then finally, distance limit, the maximum distance away from you you'd like the drone to fly. And it's easiest, I think, to talk about this in kind of an example scenario. But just getting into that return home function a little bit more, this can be triggered manually by the pilot through pressing a button on the remote control. You can stop it by holding that button again on the remote controller. It's going to be automatically triggered when the drone disconnects by default. And it's important to realize that in-app settings are based off of the home point, so terrain change is not accounted for. So just think about that in a scenario if you were at the top of a hill and you were flying away from yourself and the hill's going down, the drone reading that you're going to be receiving and that it's going off of is going to be 0 feet, even though if you flew away from yourself, it's actually going to now be, let's say, perhaps 50 feet above the ground. So important to realize that in various scenarios, whether it be legality of how high you can fly or how high you actually want your drone to go, remember that is in relation to the home point, to the takeoff point. So quick example here, we have our tree and landing pad for takeoff here. We'll say the tree in the area is 100 feet tall, so setting the return to home altitude to 150 feet, would give us a 50-foot buffer. So that seems good setting there. Maximum altitude for this flight, going by US regulations, is 400 feet since there's no controlled airspace. So want to keep the drone under that height, and maybe we give it a 50-foot buffer for some, potentially there's terrain that goes down 50 feet. So we want to make sure we're not going above 400 feet AGL. And then also need to keep the drone within line of sight. The Mavic 2 Enterprise, it's a bit smaller, maybe we're having a little bit trouble seeing it. Once again, a lot of factors for all three of these settings here, but what kind of background the drone has, do we have a beacon on the drone that we can turn on to help with visibility? But for this scenario, we'll just say 1,500 feet. And just for reference here, distance limit, it's not necessarily a line from the takeoff point to the drone where it accounts for altitude. It's just a line from one GPS location to the other. So if you were to move the drone up and down, the distance is not going to change. If you move the drone left, right, forward, backwards, the distance would change. Altitude limitation without GNSS, basically how high you can fly the drone without a strong GPS signal there. So you can set that to 98 feet or 196 feet in app. Sensor status here, key item here, but you can see your sensor status of your IMU. First of all here, you can see that's selected on the top left there. IMU stands for Inertial Measurement Unit, part of the flight controller, and the flight controller uses that data to help estimate the drone's current attitude, pitch, roll, yaw. And if your drone was in P mode and was drifting a bit, it might be a good troubleshooting step to try calibrating the IMU. You can also see metrics right there, green, yellow, red, just kind of like a stoplight in terms of the bias there for those sensors. So both excellent right now, not having any trouble with the drone, so wouldn't need to do a calibration here, but just good to know that is there. And then if you were going to do an IMU calibration, you just click on it and follow the steps. Moving over to the compass. When we're doing a compass calibration, we're basically recording the magnitude of the measured field around us and how that changes. And by doing a compass calibration, which is lovingly referred to by many as the compass dance, as you'll see here in the next slide, but a compass calibration happens a good amount. If you were transporting the drone, if you're taking off or you turn the drone on, put on a metal surface, these are things that could help kind of knock the compass off of its previously calibrated state, and always beneficial to a compass calibration. The good thing is the app will notify you in that sense, but you can also come in here into the sensor status and take a look at the compass itself. Right now we can see little to no interference. Well, if you go ahead and click on Calibrate Compass, you can make sure that no magnets or metal objects are within your area when you're going to do this, otherwise it will fail. And you can see rotating the aircraft. The way people do it for the most part is just hold the drone out and then spin themselves, or you can, hand over the drone. But it looks like you're doing a little dance with the drone, and that is the compass calibration. For RC signal lost here within the flight controller settings, this is what I talked about before, that it's default to return to home, but you can also change this to hover or land. So you could think about if you're doing an indoor flight, we're going to be flying the drone under vegetation. It would be important that if you lost your RC signal, you would not want the drone to go up and hit set obstacles. So maybe leaving it as hover or land, depending on the situation, would be a much better option. And just gotta slide ahead of myself there, as pretty much saying the same thing. Stop motor method. Basically, if we have some type of emergency, a very low probability of occurring, we have the ability to stop the motors by pulling the sticks down and in, or down and out. And that's what you'd use during an emergency. If you have that set as always, that would always be an option. If you have it set as breakdown, when the flight controller detects an issue and you did that control stick movement, the motors would stop. The idea being, in this rare emergency case, when the drone's potentially falling or spinning and coming down in an uncontrollable status, you'd rather have the blades of the drone turned off than on. Or in a super, rare case, depending, I guess, where you are, if you had some air traffic in the area and you can't get the drone down fast enough, and perhaps it would just be a last minute thing to cut the motors. So emergencies, situations for the most part there, but once again, good to know. Perception settings here, moving down the menu. First one here being the ability to enable or disable obstacle avoidance. Just for your information, turning off obstacle avoidance is not going to turn off the top and bottom sensors. And you can see the various parameters here for the Mavic 2 Enterprise series. But if the obstacle is within these parameters for the aircraft and you're attempting it to fly into the detected object, say you don't see a tree in front of you, obstacle avoidance detects it, but we're still pushing that right stick forward, trying to go into the tree, the drone's just going to stop in its tracks and hover. And even if you are applying that control input, it's not going to fly into the obstacle. There's some situations though, maybe you know that obstacle's there and you want to get closer. You'd probably want to go ahead and disable obstacle avoidance and carefully fly. Once again, that may be a situation where tripod mode would come into play when we're trying to make those smaller, minute movements, but obviously practice with tripod mode away from obstacles so you're prepared if you were going to enable it close to obstacles. Moving down perception settings here, we can see the display radar map. So basically on the main screen there, you can see I highlighted kind of same idea, green, yellow, red, red being obviously the obstacle that's detected, and we obviously don't want to run into green and yellow being a little bit farther away. And you can also see a distance there as well. Downward visioning positioning. These would be the downward sensors of the aircraft and supports the landing protection system. RTH obstacle detection. We'd want to turn this on. So say we did not set our return to home altitude properly. The drone detects the object in front of the aircraft as it's returning to home. It would go ahead and descend over that before coming down to the home point. So a nice kind of backup safety feature there if our first check of setting a return to home altitude was not correct for the situation. Precision landing here. So when the aircraft takes off vertically, it'll go ahead and collect information on the area around the takeoff point. And then when it finishes collecting that information, the precision landing will be available during the return to home. Bottom auxiliary lighting on the Mavic 2 Enterprise here. You can set that to auto, so it's going to default to on when it's taking off and landing, which is what I would say I have it on the majority of the time. On, it's always going to be on. Off, it's going to always be off. Navigation light mode, kind of flashing like the navigation light. Cool scenario I saw was some folks actually with a newer drone, the Matrice 300 RTK, and they use this bottom auxiliary light to help light railroad tracks. They had found a lost person on, and the officers were helping the person they found walk back. So by illuminating with the drone, they were able to provide some safe lighting to help them see where they were going in that situation. So cool use for the bottom auxiliary light, but obviously enabling that could be important for takeoff, landing, etc. When the drone's coming in. Remote controller settings here. A control stick mode, default, at least for most people here in the US, would be mode 2. So you can see left stick, right stick. Left stick's gonna up and down is going to control the throttle, drone going up and down. Left stick, left and right for the drone yawing. A right stick, forward and back, would be pitch, and then left and right would be roll. So right here with control stick mode, you could just change that mode if you do happen to use a different one. And then, yeah, just important to make sure you're in the mode that you're used to flying, especially if you might, share a drone with other folks. Remote controller calibration here. If you have a new RC or drone and it's not properly responding to control inputs, or it's just a new system, or remote controller calibration can be good to do. The drone has to be off for that. But basically, when our RC and we're putting a value from our RC between 1,000 and 2,000 based on how far our control stick is moved. So it's important to have that calibrated correctly, and that's sent in the data packet to the drone. So calibration can help fix that if you're experiencing some issues, or good to do with a new system, as I said, just mentioning that. Customizing RC buttons. Basically, a lot of the features we talk about during the in-flight section, or even here in the menu, just programming those to an RC button can help be a lot faster than trying to touch around on the screen, or maybe a cold scenario where you have some gloves on and you might want to take them off, or it's sunny and you're having trouble seeing the screen. So basically, if there's a function you use a lot, you'd want to go ahead and program that to an RC button. There's also the 5D button here on the smart controller in this example, and the Mavic 2 stock remote that you can program to do different things as well. You can see enable, disable the high temperature alert. Very easy to just move the button left instead of trying to do that in the menu. And then on the bottom here, remote controller linking. Really depends on what drone we're using, but you can see with the Mavic 2 Enterprise series, there's a button on the bottom right, the Matrice 300, you hold the button on the drone for 5 seconds, and that puts the drone into binding mode, but doing that remote controller linking on the RC is going to put the RC into linking mode. And basically then, when the RC is sending a data packet, the drone is going to say, okay, is this the RC I'm talking to? Yes, it is. Go ahead and accept that and read the rest of the information. For further information on how to link various drones with the RC, would check out tutorial videos or user manual, very useful in that regard. Also a tutorial part in the application for the Pilot app 1.9 on that we talked about in the previous video as well.